So I'll start with the purpose of this talk. So if you have experience with writing end-to-end tests for mobile apps, you probably know that that's the hardest part in testing for a number of reasons. Setting up end-to-end testing environment is very cumbersome. Tests are often very flaky, and tests may also be very slow. But the tests that are flaky, this is what makes them unreliable. And unreliable tests are worse than no tests at all. So in this talk, you're going to hear about the major issues that we had with end-to-end testing at Wix and how we solved them for mobile in general and for React Native specifically. So a bit about me. This is me, excited for the first day of kindergarten with my son, just like I am now. So I'm Rotem. I'm a software engineer at Wix. I'm a part of a mobile infrastructure team in the company. My team owns the mobile stack across the company. We mainly do infrastructure work, devoting lots of our time to testing methodologies and infrastructure. The unique thing about our work is that most of it is open source. So our story starts with the Wix app. It's our official native iOS and Android app. It's written from scratch in React Native. It started a bit more than 18 months ago, on March 2016. In terms of engineering efforts, the app is a cross-company effort. It currently incorporates code from 6 different product groups. There are currently about 40 developers working on the project or supporting it with infra tools, and the majority of the code is written in JavaScript. Having Google Play and Apple App Store as our means of distribution, our releases are inherently not continuous deployments. So we have a release train, 2 platforms every week. But this distribution mechanism is not the real reason we don't do continuous deployment. The reason is we rely on manual testing a lot. Currently, the full regression QA test suite contains 300 tests. And since it's so big, we can't finish testing on time for the next release. So we only test about 70 of them, which also takes a long time, about 3 person days on 1 device. In fact, if we'd run the entire suite on both platforms and just 2 OS versions on each platform times 14 days per platform, we'll end up with 56 person days for a full regression, but it gets even worse. The main concern is that manual QA cannot scale. The graph on the bottom shows the number of developed features every week. I'm sorry, guys. And the graph on the top shows the number of test suites that the QA needs to go over. So the QA test suite will always grow, meaning that even if development continues at the same pace, QA will always have additional work on each release. And since they need to test more features every week, so either we'll need to hire more QA, or we give up on some tests. But add a growing product to the mix, which needs to hire more developers and increase the development rate, and QA test suites just explode. So we don't want to hire an army of people to do manual QA. We want automated tests with modern continuous workflow that runs on CI, with a very short development feedback loop. And if all tests are green, we're confident enough to release our new version. So let's break testing down. This is a testing pyramid. I assume every one of you already know what this is and why tests are so important. So rather than talking about what it is, I'll just focus on how we test each of them. But let's just break down E2E into 2 parts. Pure UI automation, meaning no testing of external services and isolating UI testing from all the rest, and full E2E, mimicking a real user with real server data. These must run on a device or a simulator, both of them. So let's focus on mobile development and React Native specifically. So how do we test? So unit testing, business logic in React Native is mostly in JavaScript. So it's easy to test in Node. These are libraries that we developed in-house in Wix to help us define our unit testing methodologies in React Native. Component testing, we also run on Node. We rely on Enzyme by Airbnb and Enzyme drivers, which is also an in-house library to help us with mocking. But what about E2E? E2E was always hard, and it isn't as reliable as the others. Why isn't it reliable? End-to-end tests are often considered to be flaky in all platforms, web, iOS, and Android. Tests may fail without any code changes. Tests are non-deterministic. There are many moving parts inside the app, so they may finish executing in different order and different timings on different runs on different environments. So we can't really be sure when the application is idle. Users of end-to-end frameworks often have to deal with synchronization manually. So we use multiple slip functions in strategic locations just to make the test pass. So this is an example I took from Aaron Greenwald's talk in React Amsterdam. He was talking about Detox. This loop around driver slip over there is actually what we did to try preventing flakiness on our previous testing platform. So let's talk a bit about flakiness, or a bit more about flakiness. How unreliable a flaky test suite is. Let's calculate the probability of a test suite to fail. 1 minus q is the probability of a single test to succeed. 1 minus q to the nth power is the probability of the entire suite to succeed. 1 minus all that is the probability of a test suite to fail. So let's assume a test is flaky just 0.5% of times. If we have 20 tests, then about 10% of our test suites, about test runs on CI, fail. If you have 50 tests, it's about 20%. If we have 100 tests, well, you get the point. It's very unreliable. So this is a complex issue, and we've had experience with a few frameworks in the past. The most notable is Appium. Appium is the most popular solution out there. It's the de facto standard in the industry. Other frameworks like Rotem or Calabash are not under active development anymore. So the internals of Appium, its driver, is implementing UI Automator for Android and UI Automation for iOS, which are essentially external ways to interact with the device, just like a user. They're not really interacting with the app, just with the device. So we used Appium for 2 years in general, and for 2 months with React Native. And we find that we invested a lot of time writing tests and petting the CI system than actually writing features. So we found that E2E is really, really hard. First, tests are flaky. We got different results on different machines, frequent failures in CI, which the only solution was addition of slips, which slowed down the tests. Secondly, tests are already slow since Apple UI automation tool is limited to performing 1 action per second. And there is a hack for that. It is called instruments without delays, which is already unmaintained. So after each release of a new Xcode, we would have to wait for a patch before upgrading. And the benefits of testing must outweigh the cost. And frameworks which are complicated and fragile can occupy a big chunk over time. So the main characteristic of frameworks I've mentioned, all of them, is that they use blackbox to test the application. What is blackbox? So blackbox testing is a method of testing stuff from the outside without knowing what's going on internally. In mobile, blackbox E2E essentially goes over the view hierarchy, and it looks for an element, and if it's not found, sleeps, and continues looping until an arbitrary timeout that we choose or the framework chooses for us. And if found, the framework interacts with the view, and if not, it throws an exception. So same principles are applied for blackbox E2E on the web. Now, think how unfair is asking for a user to provide the timeout parameter. They have no idea what's going on inside the operating system or what's going on inside the application. So that's the main cause of flakiness. So E2E gets even worse, getting even more flaky when used with React Native apps. Let's talk a bit about rendering to better understand why. On native apps, there is only one thread responsible for rendering the UI. In React Native, it's a bit trickier, because React Native's unique architecture adds complexity to the system. Its UI rendering starts with a virtual DOM on the JavaScript thread, where all the JavaScript logic is executed, of course, which is then passed over an asynchronous bridge and is translated into native views through the UI manager. And then the main thread renders everything on the screen. So due to this asynchronous rendering mechanism, there are now two threads controlling the rendering. So blackbox testing frameworks have even more trouble controlling React Native apps. So for us, blackbox testing was a dead end. We needed a different approach. So we decided to change some of the core principles for our end-to-end testing and create a Detox. Detox does Graybox, not blackbox, to allow the test framework to monitor the app from the inside and actually synchronize with the application itself. So Graybox essentially uses a piece of code that is planted inside your app. It can help to see what's going on inside. Unlike blackbox, Graybox runs in the same process. It has access to the memory, and it can monitor the execution process. Being able to read the internal memory gives us the ability to detect what actually happens inside the application and inside our process. And with that, to see network requests in flight, or what's happening if the main thread is idle, or other threads are idle, if animations have ended, or the React Native bridge is idle. It can also execute on the main thread, which means that when it performs an action, we're assured that nothing is going under it, nothing is changing the UI hierarchy, because it also changes on the main thread. So the main thread just stays put when we do that. But there are also downsides. Usually, the Graybox testing frameworks, the app goes through a different type of compilation, or a running process, since it needs extra code to run inside the app. So for us, it was worth sacrificing this point to have a huge value in return. The leading native Graybox drivers are developed by Google: Earl Grey for iOS and Espresso for Android. These frameworks can synchronize with the application to make sure that we interact with the app only when it's idle. The underlying synchronization mechanism used by these Graybox frameworks works the following way. So instead of retrying on action or assertion on the UI, it will query these internal resources we're talking about, or whichever that we want, every few milliseconds, or listen to callbacks from these resources, and it will tell us when they switch into idle mode. And only then, the test will not continue until all of them are idle. And only then, when it's idle, it will interact with the UI. Detox also does not rely on WebDriver, since this is not the web. Detox communicates with the native driver, which we wrote, which extends Earl Grey and Espresso using a JSON-based reflection mechanism. This allows common JavaScript implementation to invoke native methods directly on the device from JavaScript. Detox has a simple protractor-like API written in JavaScript with minimal boilerplate and a very small configuration process. No need to manually sync the test with the app, no more slips. And it also can be shared between platforms. So this is how a simple test looks. So if you can see, no need to synchronize the app or wait for stuff to finish. Detox is inherently synchronized. So only when things end, it will continue to the next line. It is also cross-platform. The test code is unaware of the platform it tests. The test runner is test runner independent. This example is written with Mocha. People have already used Jest to run Detox. We're not picky. And it is debuggable. Using native constructs, such as modern async await, instead of putting everything in a promise queue, means that breakpoints will work as expected. Detox is built from the ground up for native mobile and has deep first-class support for React Native. We found that React Native pretty much re-implements iOS and Android frameworks. So apart from the basic synchronization support by Earl Grey and Espresso for native apps, we had to create special synchronization mechanisms for React Native as well. Well, traditionally, test frameworks evaluate expectations and in the test script running on the computer. Detox evaluates these expectations natively directly on the tested app running on a simulator or on a device. This enables operations that were impossible before due to scope or performance reasons. So let's take a look on a high-level diagram with a few examples that you can understand how Detox works. So first, we start with the test runner. We run an action or an expectation, and then we await on a promise. Then this expectation is being serialized into nested invocation JSON. This is the protocol I talked about instead of WebDriver. It then being relayed through a WebSocket server to the testee. This is the device. This action and expectation is invoked through method reflection, but it will only execute when the app is idle. This invocation result is being sent back through the WebSocket, and then the tester resolves or rejects the expectation promise. So let's get back to the testing pyramid. So now we have a stable E2E framework, but we still still tests may be flaky due to network or server issues. In order to do that, we'll need to remove dependencies of the tests on the network. So with expected requests and responses in consistent well-timed manner, we will create pure UI automation, which are UI hermetic tests. So we created a tool for that. Yes. So React Native Repackager. This is a mocking mechanism for React Native JavaScript code. It extends the packager's ability to override bundle files and with any other file, essentially creating an easy way to mock environments in React Native and create different flavors of your app. So we can create our own prepackaged responses and set endpoints to local mock servers. It helps a lot with separation of testing concerns. So React Native Repackager turns Detox into a UI automation framework as well. The pyramid is all green. There are no excuses. We can start testing. The surprising thing is that not only Graybox is more stable than blackbox, it's also much, much faster. No more sleeps or wait untils. The code executes the millisecond the app is idle. So it's about 5 to 10 times faster than all blackbox solutions. So let's see Detox in action. This is Detox-owned E2E tests that are run on a simulator, iOS simulator, which, of course, are written in Detox. The simulator running on the app is on the right, and the console running our tests is on the left. We use Mocha as our test runner here, but you can use whatever you want, as I said before. Every line you see on the console is a new isolated test scenario. So it restarts everything from the beginning, and it can be sharded in the future. And as you can see, it's pretty fast. But wait, this should be a cross-platform framework, right? So many have been asking about Detox support for Android. This feature is being eagerly anticipated inside Wix as well. Now, Open source is a wonderful thing. It can form collaborations and that can take projects to the next level. So this guy, Simon Ratz, is here with us. A few months back, we've been contacted by Simon. He's from KPN. It's a major telecom company in the Netherlands. He offered to help with Detox for Android. And since then, he practically became a team member of Detox, working abroad, implementing key features in our upcoming Android support. So let's see how it looks. So this is the same test suite we have been using to test our iOS implementation. It was virtually untouched. This way we could ensure that the API is truly cross-platform. Detox for Android is almost ready. In fact, there are very few things missing. And although it's not ready yet, I wanted to give you a taste of how it looks. So today, I meant to release an alpha version of the Android support, and I made all the preparations yesterday night, but it turned out that the release gods had different plans for me. As I was upgrading our demo project, I found that we've already been releasing the Android source code on every version by mistake. So if you want, you can start using Detox for Android now, actually long before now, yes, and just take a look at the configuration of the demo React Native project in our examples. But I must warn you, not all features are implemented yet, and it's not yet battle tested. So Detox is a TDD project. It has 100% code coverage, and it sets to fail builds if it gets lower than that. We run our entire Detox API on a special test app on every build. That's what you saw on the videos before. Builds run on Travis CI, and only contributions that meet the standards are accepted. So it's pretty easy to determine if a code contribution really works. Be awesome like Simon, contribute. Of course, contributions are welcome. You can use Detox today on iOS and Android. And our initial mission was to create a framework that we can trust, such that will give us confidence that if our builds are green, we can release a new version. And with that, to build a real continuous deployment workflow. In order to achieve that, we needed to change our state of mind. There is no such thing as a flaky test. Either there is a bug in the app or the test framework is lacking. And our top priority is to fight flakiness, but it's not a very easy task. So we're very excited about Detox, and we hope that you'll find it useful as we do and use it with us. So I summarized this presentation in a blog post in my private Medium account. So, of course, go ahead and read it and give me 50 claps, because there's a new thing there, yeah. And that's it. I'm done. Thank you.